So I have been modeling different multi-family approaches from around the world, mainly prompted by Cul-de-sac Tempe, which is, their marketing says, the first car-free neighborhood designed from scratch in the US, which I'm going to believe it, if you take neighborhoods designed after the car was invented. But it's cool, and you can see Tempe here, and this is sort of how it looks and feels. It's these very small, some of them like 20 feet wide, 3-story buildings, closely packed, with a variety of spaces, little courtyards, little alleys. It's really nice. It's got a European feel, and it has some advantages for the developer. The first advantage is I think it can be point loaded, and so you don't need multiple escape stairs. It probably doesn't need to be sprinkled. I'm not across the US building code as much as I should be, but it's very low. The light comes in from both sides, and the cross ventilation is very good. So a room here, like a 20-foot wide room, can have the air come across it. As opposed to this building here, which is a classic multi-family apartment, which is actually this building here. So I just copied this building over here, which is just down the road from Tempe, from Cul-de-sac in Tempe, Arizona. And you can see that's a whole lot of building, right? It's much bigger. It's almost like 90 feet wide. You can see these dents to make it a bit smaller. And the way I've modeled this is there's actually as much gross floor plate in this building as there is in all of these buildings. Like if you added all of these up together, you would get this 159,000 square feet. So these are sort of, I guess, two American typologies now. It's a land of contrasts. Here's a point tower. This is certainly an Australian typology. I think it's also an Asian type of typology. These are sort of 60 feet wide, double loaded buildings. A bit narrower than this, but sort of similar in concept. But you go high. You go high to get views, because value in Australia is certainly found on the higher levels. That penthouse feel. And then I went and copied Rome, the eternal city, and I placed a Roman block down. So these are actual blocks that I've got, and this one I just made up. But all of them are approximately the same amount of gross floor area. Right, so let's first off examine the financial implications of these things. So the gross area is the same, but the efficiency of these buildings is different. The cul-de-sac probably has an efficiency of about 90%, because there's no elevator. It's probably just stairs up, stairs down. There's no corridor. The donut has an efficiency of about 85%. It's a big floor plate, bigger than would be allowed, say, in Australia. But there's still quite a lot of plant, mechanical plant services, and also corridors and elevators. The performance of a space like this depends on mechanical plant. As something like this works without electricity, right? Which is why you can get sort of 200-year-old houses that are of this dimension, that haven't rotted or gone to mold or anything like that, because the air and the light move within them. These kind of buildings, you do need a service, because they're very deep, get very dark, very still. The air doesn't move through them because there's walls in the way. The point tower efficiency is lower because it's vertical. So every duct goes through 20 stories instead of 1 story. So I've put it at 72. And the efficiency I'm talking about here is the gross to saleable efficiency. So it's excluding the corridors. And then Rome, I've put it at 90%. And Rome's an interesting one. It's sort of, they've made the sacrifice, it's an old buildings, very old buildings, hundreds, if not thousands of years old. They've made the sacrifices that you make with cul-de-sacs. It's just point loaded. They may have retrofitted an elevator in there, but probably not. So it's extremely efficient, but it's also bulky and dense. Although I will just encourage you to notice that the difference in this courtyard shape, right? Notice how happy the old buildings are in terms of doing sort of quote-unquote irrational or funny things, but the net effect is much smaller cross-sectional depth to these buildings, so the air will move through them, right? And the light can penetrate those floor plates without electricity. Now you can see that this has come from what Christopher Alexander would say a living process, as opposed to this, which is a little more. You can see this is designed more than this is designed. Not necessarily bad, just designed. All right, so with the same gross area and those different efficiencies, you get different sellable areas. So you actually get 10,000 additional square feet within the cul-de-sac. The square foot total build cost is also different. So cul-de-sac is about $200 per square foot. The donut is 250, mainly because you've got to build a lot of corridor. You've got to build a lot of elevators and services and plant. It's also taller, so it's up to 5 stories. So the structure's a bit beefier. There's more sprinklers. There's more safety considerations. To get people out of this thing is non-trivial. You need to engineer it. To get people out of these things, trivial. You just run down the stairs and run out. Like if the fire's over here, you run that way. These things are very, very robust. You can jump out of most of the windows in this thing. They're only 3 stories, right? You can do the cartoon thing, tie the sheets together and make a rope. Point towers also have to be very highly engineered, and they're actually, the structure relatively is more, expensive, etc. So they're $400 a square foot. And then Rome, I've put at 230, somewhere in between the donut and cul-de-sac. And so when you do that, the costs play out like this, and the return actually favors cul-de-sac because I've made that as an assumption. So the square foot rent, like net sellable rent per month per square foot, I've put at $3 per month in the cul-de-sac typologies, which are Resi type A, B, and C. I've set it for $4 in the tower, that penthouse feel. It's a premium offering. And then I've set it at $2.50 for the donut Resi and the Rome Resi. Because I do honestly believe people would pay a premium to live in a neighborhood like this over something like this. Because this feels like Santorini, or it feels a bit like Paris. It feels very, very cool. And I can see, this being a highly differentiated offering. I can imagine me and my friends all living in these little huts. It'd be sweet. I think certainly people of my generation and younger would respond really well to this. And so then the profit is massive for the cul-de-sac, much bigger than the other two. But notice that this is ex-land, and the amount of land that this development has taken to get the same gross area as this development is about sort of three and a third times more. So if you only had one parcel, it's much more rational for a profit maximizing developer to build something like this, or this, as in, even if your return on cost is lower, you make a bigger absolute profit. So of course the profit incentive says build as much as possible, as much as you possibly can. Okay, but if land is scarce and the highest best use and isn't that good, if land is abundant and the highest and best use doesn't look like, the land's not being that efficiently used, which when I'm flying around here, look at this, just on-grade car parks, the occupancy of which is not high, just a brown field. Don't know all those buses. This is a bus depot, or is this just a siding? This is like self-storage, this warehouse. It looks like there's a lot of land in Tempe, Arizona. So applying this kind of density to it will still result in a profit. So I'm sure cul-de-sac are not losing any money on this. And they may be figuring out ways of getting that 3 that I've assumed up to a 4 or a 5, ways of actually really making this place sing from a desirability perspective. Okay, and so then the other thing that I'm interested in is the efficiency. So with I'm imagining a constant size of 900 square feet per dwelling, but the maths works out the same, right? The more efficient, as in the more efficient buildings have more dwellings, obviously, because they have more sellable area, less area that is not dwelling, less corridor. And I'm modeling out 2 people per dwelling, and so more people live here. And now here's something interesting: is what I modeled out is a car factor. So cul-de-sac is car free. And so what I'm applying to the cul-de-sac developments is a car factor of 0.3, car use factor, which means they use only 30% of the car use as a normal, an average person would, because they don't have a car. In these typologies, you get in a lift, you drop down, you come out, you're at your car, you get in your car, you go. That's the way you move around and experience the city. You have to find one of these, you park, there is no car park as I understand it. There may be some car parks on the fringe of this development for share cars, but it's just a mission. You'd have to walk to your car, which is going to drive your car use down. And it's going to encourage, bodegas, amenity close to you to meet that demand. And so I'm imagining you're not going to eliminate car use because you're going to go on holidays or do big moves or it'll be raining or whatever it is. But let's say we reduce it by 70%. That would mean that these 321 people, these dwellings, they save a total of 3 million car kilometers a year, right? And we get the total number of dwellings times 1.5 cars per dwelling, 20,000 kilometers per car per year. That's average. And then 1 minus B, where B is the car use factor, so the saving, right? So that'll be 0 when the car use factor is 1, so there'll be no savings. And when the car use factor is 0.3, that'll be 0.7. And so there's no savings in the Donut Point Tower or in Rome, because we're assuming those guys are just behaving like average citizens, average people. Now, the money saved annually by the community just on the car ownership is quite substantial. So what I've done is I've gone to the ATO, the Australian Tax Office, which says it costs about 72 cents all-in cost per kilometre for a car. And then I've reduced that by $5,000. So you're going to replace, you're not going to use car kilometres, but you are going to buy yourself a bicycle, or you're going to use public transport. And so I'm imagining that the other cost is $5,000 to you, which I think is high, as in, in Sydney where I am, which is not a cheap city, $2,500 is the ceiling to what you will pay on Opal. So I think there's a $50 a week limit. So it's all you can eat. And in most cities, I would imagine that public transport caps out at around that level or less. Then a good electric bike is about $1,000, but car rental, Ubers, there'll be some car use. So if people pay $5,000 a year, but they don't own a car, this community of people saves $800K a year on car ownership, which means if they borrow and they're paying back 7% in principal and interest, that's $11 million that they could take and use and pay back over time, which is incredible. And they also save a boatload of carbon, 16,000 tons over 25 years, which I'm imagining is an acceptable duration to model out for the lives of these buildings. You probably could argue that be higher, something like 50. And that's the car kilometers. Now, cars actually emit 8 tons of carbon per 20,000 kilometers, but I've divided that by 2 because, again, you're not going to fully eliminate your carbon use. Like when you catch an Uber, you're going to emit carbon. But in general, if you are using your feet and you're walking around on bicycle, or you're walking and riding, and your amenity is close to you, you will emit less carbon. And so these are decent numbers. And what I'm interested here is how they tie into a vision that I reckon you could sell. I reckon you could sell this in any city in the world. I think I actually believe you could go denser, as in the commercial imperative to get the donut is high, because you make a return for every square foot of area, every square meter of area you construct. So the more square feet you construct, the more return you make. And Rome is actually an optimized cul-de-sac. Like Rome was designed before the cars, before carbon, when energy was expensive, when active transport was the only transport essentially. And so I think you can derive really good high quality built form from this kind of typology, which is closer to this than this. I think a lot of what's driving this is code, how you rescue people, how you evacuate people, hose length for fire, in the absence of safety systems and sprinklers, etc. But I think this is, these guys are actually building this, so incredible. Well done. They've sold it, they've financed it, they've built it. So that's an amazing, it's always easy to talk in theory. It's very, very difficult to actually get something different done. So incredible outcome. So yeah, I'd be interested to hear about other people's. So two things. I'd be interested to hear in, have I got my my figures right? So I've done a fair amount of Google foo to get these numbers, and I think they're okay. But I'd love to have them pushed back on if they're wrong. I'd also love to hear whether my gut instinct on this being an extremely attractive kind of build form is right. Okay, and the last thing I'll sort of talk about is the other thing that I really like about this build form is that each of these is separate. Each of these is a separate building and could be delivered by a separate developer or builder. Right, so if this building burns down, it's not the end of the world. You just move it, right? You just kill it, or you demolish those 5 and you build a big one. Like if in 10 years' time, if things are going terribly, we copy paste and we do something like this, right? We get maybe it's a school, maybe it's a dense building, maybe it's just we're not getting the density we need, and we just do that, right? I would suggest that we try and keep them as small as possible, but there's really nice features to this layout, robustness and redundancy to this kind of a layout, or this kind of a build form that these two definitely don't have. This one actually does have, because these are separate buildings.